Moving on to the next question. Next question says that a figure shows a binary counter with synchronous clear input. With the decoding logic shown, the counter works as, again you have to find out the mod. Very easy question. This is what? This is a XNOR gate and clear is active low. So whenever the output is equals to 0, it will clear itself, and up to that we have to count, right? Very simple concept of these counters. Whenever the clear input is given, the clear value is given, it will start again with the initial values, right? So this is XNOR. So you know the table for XNOR. So whenever same values of inputs are there, its value is 1, otherwise it's 0. If I give you very clear picture without any table for this question, so either of these values should come, right? Sorry, either of other two values. Instead of these, either of these two values should come. So Q3 and Q2 are happening. So 0, 1, 0, 0, 1, 0, 0, 0. So which will occur first? Which will happen first? Which counting will come first? So this counting will come first, right? So this counting will first come. This is what? 4. If we start from 0, it count up to 4. So that is mod 5 counter. Now let me give you the table. So this is your clock. This is Q3, Q2, Q1 and Q0. Right, and this is your clear signal, which is active low. So it should be 0 in order to clear the counter. So at clock 0, so it will be counting 0, 0, 0, 0. So clear is 1, because this and this XNOR is happening. At clock 1, it will count 1, 0, 0 NOR is 1. At clock 2, it will count this. It will again be 1. At clock 3, it will count 3. It will again be 1. At 4th clock, it will count 4. Now 0, 1 XNOR will be equal to 0. So now this is the clear signal. Now clear will become active low. So it will count up to 1, 2, 3, 4 and 5. 0 to 4, that will be mod 5 counter. Initially I have told you mod 5 counter, you can write it as from 0 to 4 or from 1 to 5, whatever. Okay, so moving on to the next question. Okay, very similar kind of question. So it is also a mod n counter using synchronous binary up counter with synchronous clear input is given. The value of n, you have to find out what up to what it is counting. So first shortcut, then table. Okay, so this is what? This is a NAND gate. NAND gate. It is again active low, so output should be equal to 0 in order to clear the counter. So its value should be 1 and 1. The input should be 1 and 1. So Q, B and this should be 1, this should be 1, this should be 0 and this should be 0. So that will be the first number, and this is what? This is 6. This is 6 we are counting. 0, QC, QD, QC, QB and QA. So 0, 1, 1, 0 is nothing but 6. From 0 to 6 if we are counting, so that will become your mod 7 counter. Now let's just draw a quick table, which is actually not required. If you understand this, QD is your MSB, QA. Clock, clear. 0, it is up counter, it is counting up. So clear is, here it is 1. First clock. Counting 1, counting 2, counting 3, counting 4, counting 5, counting 6. 2, 3, 4, 5, and 6. So it is 1, 1, 1, 1, 1, and here QC QC QB naught will become 0. So that will be your mod 7 counter. Clear? Very easy question. These kind of question you can like directly write solve from here. Just whatever the input it make according to the situation. Find out the output. So if it is active low, it should be 0. According to output, find out whatever input is required. So it should be 1 and 1. Keep other bits equal to 0. That will be the value of mod. Okay. Since it will become 6, we have to count from 0 to 6. That will be a mod 7 counter. It will count up to 7. Now this circuit, this is very simple circuit. This is a master slave. So this is not a toggle flip-flop. This is not a T flip-flop. Toggle means only T flip-flop. Okay. So this is D latch is given. So this is not T flip-flop. This is not JK. This is not SR. This is a master slave D flip-flop formation. Okay. Master slave formation is done by this. If it is a D, you can also form master slave by JK. So this one is master and this one is slave. Okay, next question. So next question says that the output of the two flip-flops Q1, Q2 in the figure are shown are initialized to 0, 0, the sequence generator at Q1 up to the application. The output of the these are Q1 and Q2 having the initial value 0, 0, the sequence generator on Q1. Okay, you have to find out the sequence. What will be the sequence? Which of the following will be the sequence generated at Q1? Let's just see what is happening. So this is a synchronous type of counter because clock is given, same clock is given to both the J and K flip-flop. Now we have to find out the values for Q1 only. Okay. Here, J2 is equals to Q1, J1 is equals to Q2 dash, K1 is equals to Q2, and K2 is equals to Q1 bar. According to circuit, we can see them easily. So J1 is equals to Q2, K1 is equals to, J1 is equals to Q2 bar, K1 is equals to Q2, K2 is equals to Q1 bar, J2 is equals to Q1. We can see it directly from the circuit. Okay. Now what they are saying, what sequence will be drawn if initial values are this. So let me write it. Q1, Q2, these are previous state. J1, K1, J2, K2, and Q1, Q2 dash dash. Next state. These are your next state. So initial values are given as 0 and 0, first clock. This is your clock also I'm drawing. So at initial value, I am writing it here again. So J1 is equals to Q2 bar, K1 is equals to Q2, J2 is equals to Q1, and K2 it is equals to Q1 bar. Clear? So J1 value will become Q2 bar, that will be 1. K1 value will become Q2, that is 0. J2 value will become equal to Q1, that is 0. And K2 value will become Q1 bar, that is equals to 1. I have to draw excitation table also. The excitation table, where should I draw? Let me draw it here, very small. Output. If they are 0, 0, the value should be equal to Q, previous state. 0, 1 will be equal to 0, 1, 0 will be equal to 1, and 1, 1 means toggle. Qn bar. Right? So this is what is happening. So J and K is 1 and 0. So 1 and 0 means Q1 value will be equal to 1. And if it is 0 and 1, its value will be equal to 0. So this, after first clock, this next state will become your previous state, 1 and 0. According to this 1 and 0, again you have to find out all the values of J and K, and then next state, and you have to repeat this cycle whenever the sequence formed is repeating itself again and again. No, yeah, this is not there. You have to find out this sequence. Whatever sequence is this, whether it is this, whichever sequence is correct. So firstly, we found out the value of Q1 is equals to 0, then it is equals to 1. Okay, let's just find out more options, because these two initials are there for many, 3 options. Okay, so when Q1 is equals to, now J1 is equals to Q2 bar, which is equals to 1, K1 is equals to Q2, which is equals to 0, J2 is equals to Q1, which is equals to 1, K2 is equals to Q1 bar, that will be equal to 0. So 1, 0, 1, 0 will be equal to 1 and 1. So second clock, this will, the next state will become, the next state of previous clock will become the previous state of next clock. 1 and 1. Now in case 1 and 1, J1 is equals to bar and 1. J2 is equals to, this also is present, right? Yeah, this 1 and 1 option is also there. 2 ones, 2 ones. Okay, we have to find one more state in order to get the correct option. Okay, so J1 is equals to Q2 bar. So Q2 bar is 0 and K1 is equals to Q2. J2 is equals to Q1 and this is equals to Q1 bar. So 0, 1 is 0 and this is 1. So it will become, at third clock, it will become 0 and 1. So now this is the sequence is following. So this sequence is not this, not this, not this, but this is the following sequence. You can find out more, but they are just asking you to find out the sequence of Q1. So sequence is 0, 1, 1, 0 and so on, whatever. Okay. If you want, we can find out next also, because the given option is up to 0, 0. So let's just do it. So J1 is equals to Q2 bar. So that is equals to 0 and K1 is equals to Q2. J2 is equals to Q1, 0 and K2 is equals to Q1 bar. That is equals to 1. So 0, 1 is 0, 0, 1 is 0. Yeah, here you can see it is 0, 0 on fourth clock pulse. This is your sequence 0, 1, 1, 0, 0. Option D is satisfying this. Great. Sorry. Moving on to the next question. Okay, next question says that in the circuit shown, choose the correct timing diagram of the output Y from the given circuit waveform W1, W2, W3, W4. Which one of the following is the correct timing diagram? So this is D flip-flop, this is D flip-flop and output is, this is suppose Q1, this is Q2, Q1 and Q2. So output Y is Q1, Q2. Okay, D flip-flops are transparent flip-flops. Whenever the value of D is 0, the value of Q is also 0. The value of 1 is, D is 1, the value of Q is also 1. So you have to AND the output. Now, which of the following is correct? W1, W2, W3, W4. Now we have to check. So and you know the and table. So output inputs are Q1, Q2 and Y. So if they are 0, 0, output is 0. This is it. Right. So now you have to see. It is 0, it is 1 and it should be 0. So it is 0, it is 0. Yeah. These are reject. This is also 0 till here. It is 0 here. It is also 0 at some point. So it should be 0. It means it should be 1 for the complete. This is clock. It should be 1 for complete clock. Right. This is your 1 clock, right? 1 clock. It should be 1 for a complete clock cycle. So no such thing is given. Now here also, this is 0 is here. This is 1. This will become, this should be 0, 0. This is not 0. This should be also 0. This is 1. This is 1. I think W3 is satisfying it. Any of the other waveform is not satisfying it, because you see here it is 1. Here it is some amount of 0 is there. So a 1 is not satisfying here. Here in this part it is 1. Here it's some part is 0. Here in this part it is 0. So W3 is the correct option. So W3 is satisfying because other parts are becoming 0 for some ranges, but only in the last one it is becoming 1 purely. For this particular clock, if you see, it is also 1, it is also 1. So here 1, otherwise it's all 0. Okay. Moving on to the next question. So next question says that there are 5 JK flip-flops are cascaded to form the circuit shown in the figure. The clock pulses at a frequency of 1 megahertz are applied as shown. The frequency in kilohertz of waveform Q3 is. They are asking you to find out the frequency. The total frequency is given as 1 megahertz. The frequency here of clock pulse is 1 megahertz. Now, what happens? A very general thing about flip-flops, when we are talking about only one flip-flop, suppose the clock frequency is F0, the output frequency of one flip-flop, be it any flip-flop, will become F0 by 2. Right? And here the flip-flops are being cascaded. Right? They are cascaded. The output of one is given to the clock of other. The output of next is given to the clock of a next one. So they are cascaded like this. They are asynchronous, but output of the LSB is given to the clock of the next one. Similarly, and going on like this. So if here the clock frequency is F0, the clock frequency at this will become F0 by 2. Here F0, it will become F0 by 4, right? Here F0 by 4 will become F0 by 16, right? And we have to find out the frequency of the output of Q3. So that will be F0 by 16, which is equals to 1 megahertz by 16, which is equals to 62.5 kilohertz. So that is your correct answer. 62.5 will be your correct answer, right? So this is how you can easily find it out. Okay, moving on to the next question. So next question is again on state transition diagrams. So there is a D flip-flop which is connected to a mux, 2x1 mux, and they are asking you to find out the correct logic diagram. So now here A is the select line. A is the select line. Now what's happening here? If a value is equals to 0, if a value is equals to 0, it is selecting what? Q bar, right? And if a value is equals to 1, it is selecting what? Q, right? And what does Q and Q depends on? If D value is equals to, depends on D value. So whatever value of D is and D bar. That means whenever we are having A is equals to 1, if we talk in terms of state diagram, it will remain in the same state, right? It will be in the same state. It is not toggling. And when we are having A is equals to 1, it toggles the state. It moves to the another state. This is what is happening, right? So when A is equals, suppose when D is equals to, let me write it properly, D, which is equals to Q. So when D is equals to 0, Q is also equals to 0. And when D is equals to 1, Q is also equals to 1, right? When these are equal to, this is equals to 0, it is, whether if it is D is equals to 0 and this is equals to 0, if A is selected this x1, that means x value, A value is 1, its output will be equal to 0. It remains in the same state, right? If A value is equals to 0, its value will become 1, the next value. Suppose, and if D value is 1, Q value will also become 1. If A value is 1, it will remain in same state. It will remain in, the output will be 1 only. But if A value is 0, the output will be next one. So which will be satisfying it? Here A is equals to 1, moving on to the same state, correct. But here at A is equals to 0, it's moving on to the same state, wrong. This is also wrong because it should move on the same state when A is equals to 1. This is also wrong. Here it is also wrong. It is correct. At A is equals to 1, it is keeping the same state. And when A is equals to 0, they are moving to the another state. They are toggling, right? They are moving to the another state. This is what is happening. So D option will be correct answer. If I write it here again, suppose D value is 0. So this value is also 0. This value become 1, right? If A value is 0, output will become what? 1. So that means it will toggle. If A value is 1, the output will remain as 1. Its value will be same. It does not toggle at all. So this is what is happening. Right. So option D will be your correct state diagram for the given question.